Hi everyone and welcome to our presentation. My name is Cheyenne Nelson. My group is Group 4. My group members are Leona Clark, Sandra Gaynor, and Nicole Thomas. Today we'll be talking to you about the nephron. We will be showing you a label diagram of the kidney nephron describing the function in the urine formation with respect to the microscopic structure, ultrafiltration, absorption, secretion. Also, we'll be explaining the role of the kidney with respect to osmolarity of the blood. Sit back and be educated.
Hello everyone, my name is Leona Clark. Today I will be presenting on the joint of the kidney nephron. I will just be showing you where the labels are, and further down in this presentation you will know what each labeled part of the diagram does and how it affects or affects the kidney nephron. Now, right here is the afferent arteriole. Beside the afferent arteriole is the efferent arteriole, which is this loop right here. Below the efferent arteriole is the Bowman capsule, which is this cup-like shape of part of the joint. Now, right here is the proximal convoluted tube, which is this tube that continues on to the side. Beside the proximal convoluted tube is the glomerulus, which is located inside the Bowman's capsule. Now, down here is the distal convoluted tube, which is a part of the proximal or is close to the proximal convoluted tube. To the side here is the collecting duct, and over here is the capillary network. Last but not least is the loop of Henle, which is this tube that has a loop here. Thank you for listening, and as I said, continuing in this presentation, you will learn what each part of the diagram is about.
Hi everyone, my name is Sandra Gaynor and I'm a member of the Group 4 AMP group. Today I'm going to talk a little bit about the microscopic function of the nephrons and ultrafiltration of the nephrons. The word nephron comes from the Greek word nephros, meaning kidneys. The nephron is a microscopic, functional, and structural unit of the kidneys. Its functions includes filtering the blood from impurities and modified it into urine and regulates the blood pressure. It controls electrolytes and balances the plasma to homeostasis. It is consisted of renal corpuscles that filters the blood, and the renal tubule modifies it to filtrate to form urine. Ultrafiltration. This is a process of filtering the blood under high pressure in the glomerulus. During filtration, blood enters the afferent arteriole and flows into the glomerula, where the filterable blood components such as blood, water, and nitrogen waste will move towards the inside of the glomerular, and the non-components such as cells and serums will move via the efferent arterioles.
Hello again everyone as I continue with reabsorption. As filtrate travels along the length of the nephrons, the cell lining in the tubule selectively takes substance from filtrate and move them out of the tubule into the blood. Recall that the glomerulus is simply a filtrate and anything suspended in the plasma that fits through that holes in the filtration membrane can end up in the filtrate. In the renal tubules, essential substances such as glucose, amino acid, electrolytes from filtrate reabsorb back into the blood. This process occurs through active or positive transport, mainly in the proximal convoluted tubule, where about 65% of water and sodium and 100% of glucose and amino acid are reabsorbed. The filtrate that is not reabsorbed becomes urine at the base of the collecting duct. As I continue with secretion. Secretion is the process of selectively removing unwanted substance from the blood, adding them to filtrate. This takes place mainly in the distal convoluted tubule and the collective ducts, where the tubules selectively secrete ions, example, hydrogen, amina, potassium, and some other drugs in the tubular fluid. Additionally, they help the body maintain acid-base balance and the electrolyte balance without affecting overall body levels.
Good morning, everyone. I am Nicole, and today we'll be talking about the role of the kidneys in respect to osmolarity of the blood. First, let's talk about what is osmolarity of the blood. It is an estimation of the osmolar concentration of plasma and is proportional to the number of particles per liter of solution. It is expressed as mmol/L, which stands for millimoles of liter, millimoles per liter. The normal range in adults is 306 mmol/L. So in other words, this refers to the total concentration of solutes in the blood. Solutes are, for example, vitamins, minerals, sugars, amino acids, lipids that are dissolved in the blood. What is the role of the kidneys in blood osmolarity? We all know that blood flows into the kidney through the renal artery. It is then filtered by these tiny blood vessels in the nephrons called the glomeruli. The kidneys are responsible for maintaining the osmolarity of the blood. They do so by balancing the ratios of solute, again, vitamins, lipids, to solvent blood. The kidneys control the amount of water and other substances in the blood. When there's an increase in the ratio of solute to solvent, too little solvent, that is, high concentrated amounts of vitamins, minerals, to less blood, then this leads to an increase in osmolarity. An increase in osmolarity of the blood triggers the hypothalamus to release antidiuretic hormone ADH or vasopressin, which signals cells in the kidney tubules to reabsorb more water inside the blood, and this leads to a return to normal osmolarity. When there is a decrease in solute minerals and an increase in solvent blood, then this leads to a decrease in osmolarity. Osmolarity decreases when you have too much water in your blood. When osmolarity is lowered, ADH secretion decreases, resulting in the excretion of excess water, and the blood osmolarity returns to normal. Thank you so much for listening today. Have yourself a great day.